Michigan, while there isn't a specific low-voltage license, you'll typically need an electrical license to work on low-voltage systems. The type of license you need depends on the scope and complexity of the electrical work. Oakland Community College offers a construction electrician program with a low-voltage focus in Farmington Hills, Michigan. Lansing Community College in Lansing, Michigan provides a low-voltage electrical technology program. Northwestern Michigan College in Traverse City, Michigan has a low-voltage electrical technician program. For electrical installations involving over 100 amps or 300 volts, an electrical master license is required. For installations involving up to 100 amps or 300 volts, an electrical journeyman license is necessary. Those learning the trade can work under the supervision of a licensed journeyman or master electrician with an apprentice electrician license. The Michigan Department of Licensing and Regulatory Affairs, or LARA, doesn't mandate a separate low-voltage license. Obtaining one of the electrician licenses is highly recommended for both safety and to ensure compliance with regulations. It's important to understand the distinction between line voltage and low voltage in electrical systems. Line voltage, also known as mains voltage, refers to the standard voltage level provided by the electrical grid. In North America, this is typically 120 volts or 240 volts. Low voltage, on the other hand, is generally defined as 50 volts alternating current or 75 volts direct current or less. Common applications of low-voltage systems include lighting, control circuits, security systems, and communication networks. Because low-voltage systems operate at low voltage levels, they are often considered safer to work with than line-voltage systems. However, it's crucial to remember that even low-voltage circuits can pose electrical hazards if proper safety precautions aren't followed. When working with any electrical system, it's essential to de-energize the circuit whenever possible. This means turning off the power at the circuit breaker or disconnect switch before starting any work. If you can't energize the circuit, use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Always use tools that are rated for the voltage level you're working with, and never work in damp or wet conditions. In Michigan, the Michigan Electrical Code governs the installation and maintenance of electrical systems, including low-voltage systems. This code is based on the National Electrical Code, or NEC, which is a widely adopted standard for electrical safety in the United States. The NEC provides detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical installations. It's essential for anyone working on electrical systems in Michigan to be familiar with the Michigan Electrical Code and the NEC. These codes help ensure that electrical systems are installed and maintained safely, reducing the risk of electrical shock, fire, and other hazards. To further elaborate on the electrical licenses available in Michigan, let's examine each one in detail. Firstly, the Electrical Master License. This is the highest level of electrical license in Michigan, and it allows the holder to perform a wide range of electrical work, including the design, installation, and maintenance of electrical systems. To obtain an Electrical Master License, you must meet certain requirements, including completing a specific number of hours of experience working under the supervision of a licensed master electrician, passing a written exam, and meeting certain educational requirements. Secondly, the Electrical Journeyman License. This license allows the holder to perform electrical work under the supervision of a licensed master electrician. To obtain an Electrical Journeyman License, you must complete a specific number of hours of experience working under the supervision of a licensed master electrician, pass a written exam, and meet certain educational requirements. Thirdly, the Apprentice Electrician License. This is an entry-level license that allows individuals to learn the electrical trade under the supervision of a licensed journeyman or master electrician. To obtain an Apprentice Electrician License, you must register with the Michigan Department of Licensing and Regulatory Affairs and work under the supervision of a licensed electrician. It's important to note that each of these licenses has specific requirements and limitations. For example, an electrical journeyman license typically has restrictions on the size and complexity of the electrical systems they can work on without supervision. It is vital to research and understand the specific requirements for each license before pursuing it. In addition to the licenses mentioned above, Michigan also offers specialty licenses for specific types of electrical work. For example, there are licenses for fire alarm systems, security systems, and low-voltage systems. These specialty licenses typically require additional training and experience in the specific area of electrical work. When choosing a training program for low-voltage electrical work in Michigan, it's essential to consider several factors. Firstly, the program's curriculum should cover the fundamentals of electricity, including electrical theory, wiring methods, and safety practices. Secondly, the program should provide hands-on training in the installation and maintenance of low-voltage systems. Thirdly, the program should be taught by experienced instructors who are knowledgeable about the electrical industry. Fourthly, the program should be accredited by a reputable organization. Fifthly, the program should offer job placement assistance to help graduates find employment in the electrical field. Finally, the program should fit your budget and schedule. Consider the cost of tuition, fees, and books, as well as the length and format of the program. Some programs are offered on a full-time basis, while others are offered on a part-time basis. When working on low-voltage systems, it's essential to follow safe work practices to prevent electrical shock and other injuries. Firstly, always energize the circuit before starting any work. Secondly, use appropriate personal protective equipment, such as insulated gloves and safety glasses. Thirdly, use tools that are rated for the voltage level you're working with. Fourthly, never work in damp or wet conditions. Fifthly, inspect your tools and equipment before each use to ensure that they are in good working condition. Sixthly, follow all applicable electrical codes and standards. Seventhly, if you are unsure about something, ask for help from a qualified electrician. Grounding is an essential safety measure in electrical systems, including low-voltage systems. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. All electrical equipment and enclosures should be properly grounded according to the NEC. The grounding system should be regularly inspected and tested to ensure that it is functioning properly. Overcurrent protection is another essential safety measure in electrical systems. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices automatically interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. Circuit breakers and fuses should be properly sized for the circuits they protect. They should be regularly inspected and tested to ensure that they are functioning properly. Wiring methods for low-voltage systems are similar to those used for line-voltage systems. However, there are some specific requirements that apply to low-voltage wiring. For example, low-voltage wiring must be properly insulated and protected from physical damage. Low-voltage wiring must also be installed in accordance with the NEC. Common wiring methods for low-voltage systems include the use of non-metallic sheath cable, or Romex, flexible metal conduit, and rigid metal conduit. The choice of wiring method depends on the application and the specific requirements of the electrical code. When installing low-voltage wiring, it's essential to follow proper wiring practices to ensure a safe and reliable installation. This includes properly terminating wires, making secure connections, and protecting wires from physical damage. It also includes properly grounding the wiring system. Troubleshooting low-voltage systems can be challenging, but there are some basic steps that can be followed to identify and resolve problems. Firstly, start by visually inspecting the system for any obvious problems such as loose connections, damaged wires, or blown fuses. Secondly, use a multimeter to measure voltage and current levels at various points in the circuit. Thirdly, compare your measurements to the expected values to identify any discrepancies. Fourthly, use a systematic approach to isolate the problem to a specific component or section of the circuit. Fifthly, once you have identified the problem, repair or replace the faulty component. Finally, test the system to ensure that it is functioning properly before putting it back into service. It's also important to understand the different types of low-voltage systems. Firstly, power-limited tray cable, or PLTC, is a type of cable specifically designed for use in low-voltage power circuits. PLTC cable is typically used for control circuits, instrumentation circuits, and other low-voltage power applications. Secondly, Class II circuits are low-voltage circuits that are limited in both voltage and current. Class II circuits are typically used for lighting, control circuits, and other low-power applications. Thirdly, network cabling. This type of cabling is designed for data transmission. Common types of network cabling include twisted pair cable, coaxial cable, and fiber optic cable. Fourthly, fire alarm systems. These systems are designed to detect and alert occupants to the presence of a fire. Fire alarm systems typically include smoke detectors, heat detectors, and manual pull stations. Fifthly, security systems. These systems are designed to protect property from theft and vandalism. Security systems typically include door and window sensors, motion detectors, and security cameras. The NEC Article 725 covers the requirements for Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. Class 1 circuits are those that exceed the voltage and current limits of Class 2 and Class 3 circuits. Class 2 and Class 3 circuits are power-limited circuits that are considered safer due to their lower energy levels. Article 725(21) covers the overcurrent protection requirements for Class 1 circuits. It specifies that Class 1 circuits must be protected by overcurrent devices rated at not more than the ampacity of the conductors. Article 725(31) covers the wiring methods for Class 2 and Class 3 circuits. It specifies that Class 2 and Class 3 circuits must be separated from power conductors and must be installed in a neat and workmanlike manner. Article 725(52) covers the grounding requirements for Class 2 and Class 3 circuits. It specifies that Class 2 and Class 3 circuits must be grounded in accordance with Article 250 of the NEC. In conclusion, working with low-voltage systems in Michigan requires a thorough understanding of electrical codes, safety practices, and the specific requirements for different types of low-voltage systems. While a specific low-voltage license isn't mandated, obtaining an electrical license, such as a master, journeyman, or apprentice license, is highly recommended for safety and compliance. Furthermore, participating in a comprehensive training program and staying updated on the latest electrical codes and standards are crucial for a successful career in the low-voltage electrical field.